Alright, another DraftScience video presentation. Bit discouraged mode. So I saw my I looked at my analytics, and I'm down to 2 subscribers a month. It's almost like, why bother? Obviously, exposure for the obscure channels. YouTube is decommissioning them. The channels without ads, are just going to find it harder and harder to gain any audience or traction. They have to use the other media. I guess I have to get a Facebook account and a Twitter account, and that is just so unappealing. But anyway, jeez. I hate the internet now too. Everything's just turned to shit. Everything is shit. So anyway, I'll do a couple of comments. It's these people are really quite funny. I mean, funny like, oh, this really is tragic. Insults where they say something like, "Weren't you a singer from the band Whitesnake?" Well, the singer in Whitesnake, there's really only one, and pretty good-looking guy. Thanks. So that you were supposed to be insulting me, right? Oh, I get it. But I mean, just so stupid. Man, I love that bit. This. You think this is showing how impressive your argument skills are? Like, oh, the audience is so smart, and they can make such great arguments in defense of the classical physical description of reality. This is what you have to resort to? I mean, it's just funny. Oh, shit. So, yeah, fuck off. Oh, amazing crap. I mean, right when you do this, right in front of them, and point out how this kind of argument is really not going to impress me, It's only going to re-emphasize and reinforce my perception that you're all fucking brain capable. That you're really not, you're all yellow busters. You're not even coming close to doing this, oh, I can use my brain in some sophisticated and meaningful way. No, you're really not showing any of that. Yeah, I think I'll just block him. He probably will not recover and make some recovery comment. And so there, I'm down to 1 subscriber this month. Oh, whatever. This is so bad. All right, so then this guy, I guess I don't know if he's making a point. I mean, it's a response to a video where I'm basically pointing out how all of their physics is really completely unevidenced and illogical. Like, you can't even intuitively know anything about what it is. A virtual photon that pushes and pulls, bent space. I mean, what the hell? How can you have an intuition about something as silly as a bent space? But whatever. So he says, when I'm trying to wrap my head around this intuitively, the intuition is just like push versus pull. See, that's the first one you should challenge yourself with. It's just to go, well, yeah, how exactly would I make a physical pull? Physical push, really easy. Physics push, yeah, really easy. How do I make a physics pull? And that's your challenge. But instead, you're using your intuition to do something a lot more complicated. But anyway, I'll go through some of this crap. The bits of momentum that you describe seem to be infinitely small. I don't know why you would seem to think they were infinitely anything when I'm pretty clear I don't like the word infinity much. But it is possible. You think, if there was something called space, you just made nothing. The truth is, there's no size limit to how small can be. You can really just keep going. Now, infinite is kind of a silly word, I would argue, but I'm just saying there's really no way to point out where the stopping point would be. But in no way have I implied that this stuff has any of those characteristics, that the physical universe is very Plankey. So I'm still very much in the Planck mood. Okay, so the one thing they did do right, Planck, pretty good. Quanta, some sort of standard little bit. I don't have a problem with that. So anyway, even when compared to electrons. So again, where would you get the notion that I think photons are infinitesimally small compared to electrons? They have to move electrons, huh? you know. So they have to have some relative power. Now, whether it's 100 to 1 or 1,000 to 1, I can't say for sure. But it's in those kind of ranges. It's not in the gazillion, bazillion to 1. Nothing I've ever said implies that. I mean, they actually have to hit the electrons. Okay, even when compared to electrons, and also really infinitely packed together all over the universe. Well, I mean, compared to our size, they are, you might as well say they're infinitely small, because, yeah, compared to us, they're really, really small. There's a lot of them going in all directions. Yes, so exactly. All right, so this is reason to get to a different subject, or a similar subject, but it's, relevant to what he's saying. No one really talks about this kind of stuff. The standard model, doesn't really have any clues, and it doesn't really explain any of this, doesn't draw you a picture of any of this. But yes, clearly what wasn't on the list that I should put on the list is the fact that I don't believe, okay, that there's this is, if a proton was a grain of sand, okay, on the 50-yard line of a football field, the nucleus of an atom, that the electron was, in Minnesota. That this thing is made out of 99.9999% empty space. That doesn't really wash. Okay, that these things, so they've made them all point particles for their mathematical purposes. For mathematical purposes, they're just going with a location where the center of its gravity, so to speak, is, or the center of its charge. So that's how they mathematically see everything, as a point. You are just a point. This is just a point. Everything's just a point mathematically. But that's not the reality, in my opinion. There's just no logic to it. So why don't you use your intuition? Why don't you ask conventional physics with your intuition, how the hell a photon ever hits atoms? I mean, if the electrons are, infinitesimally small and the nucleus is even smaller, almost, how the hell do you ever hit the thing? Right? I mean, how many bazillions of atoms would you have to go through before you actually hit an electron? So it doesn't really make any sense, does it, to you? I mean, it doesn't make any, and yeah, and then I forgot, this thing's supposed to be moving, at 400,000 miles a second or something. So the fact that you buy all that crap, yeah, I'd say your intuition is broken, and I'm trying to correct your intuition to understand, no, think about it realistically, not unrealistically, okay? Think about it like this is a magnetic position, and this is a magnetic position. You could understand if, if you set up like this was a south-facing magnet and these were little north-facing magnets, that you could arrange north-facing magnets in such a way, okay, that they, although they're attracted and want to go in, they can't get there because each one of them has a problem. It has to push on the other north magnets to get there. And so the pressure to push the north magnets away is just as strong, okay, as the pressure to go towards the south end. And you could understand that a magnet would be sort of stuck here because it really can't go to this position without getting closer to these other northers and forcing them in directions they don't want to go, so they're going to fight back and push back. And so you're going to end up with a balance, okay, of pressure. Now, to me, that makes a lot more sense as a model of the atom. All right, and it certainly makes it a lot easier to share an electron, right? If I'm two atoms and I want to share an electron, well, bingo, it's really easy. I just put another south here and then put my little norths over here, and there, I shared the electron. Really easy to do. It makes perfect sense why this now is pretty important, because neither atom wants to give it up. So it's a pretty strong bond, everything's tied, quite, lots of connections, and so not so easy to break. And then you could have two of those, you could connect to two of them and you have an even stronger bond. So I'm saying this model makes a hell of a lot more sense than this swirly figure eight kind of crapola that somehow the electron is flying back and forth and, oh yeah, I'm keeping the atom connected by doing all this swirly crap. And the swirly crap they can't even explain because, it has to be some sort of perfect gravitational orbit. It doesn't even make any sense that it would ever be able to stay, that it would ever be able to avoid crashing into the nucleus and all that kind of crap. So this is a much stabler drawing. So let's just take this as being the truth, the intuition now. And now what you're really saying, now photon, I'm arguing, is some kind of energy that has a pattern to it. Now, I'd like to draw it like this, like, oh, here's the pattern, okay, and here's the atom. No. See, we know the polarization of the photon. Now I have to use the, it's off the screen, okay? The polarization is way off the screen. Thousands of atoms of polarization for the pattern called the photon. The pattern called the photon can't possibly hit one electron. And they have no evidence that one photon hits one electron, okay? So let's understand they really don't have any evidence for any of this stuff they claim to be the function. And what the photon really is this a piece of a photon can make it, and that can hit an electron. And then another piece hits a different atom. See, this atom pushes, this electron pushes that. See, it hits here, this electron pushes. That means, let's come on the other side of the screen, that means that atom pushes on this atom, moves its electrons. See, and then the other piece hits, just when this arrow is going here, the other piece hits here, or let's say it hits here, right? So the second piece hits another atom here while the energy is going this way. And you can sort of understand, as this one pushes here, it means it's pushing this electron this way, and now it's going to get pushed this way. And so now it's going to have a much stronger vector this way, and that stronger vector this way means it might push this electron right out of the atom. And that's the photon. The photon is a pattern that happens over a field of atoms. So I'm just saying, you can't do this, you can't just say my intuition, I mean, some of this physics isn't going to be anywhere close to just using intuition. First you have to get the model correct. I mean, applying your intuition to an incorrect model isn't going to work. And obviously in one video I can't give you all the modeling information, but I have over the course of time done that, and so it's unfortunate that you haven't just watched enough videos apparently to understand that this is the real scenario. Now, how big electrons really are, now I could draw them this big, and I'd say that's more realistic because at least you have a chance of hitting this thing. But I could argue that they might be this big. Okay, they might be really big. And there's every reason to think they have to have some volume to them in terms of some capacity to catch a force, because photons would never hit them if they were what the standard model says they are, some kind of infinitesimal point. Okay, there's no chance you could interact with them. Yes, they would not be taking up enough space. And the fact would be is that when you went into a material, I mean, they have experiments for this, how many layers of atoms they have, and they kind of know that they can make a mirror where they get all the reflections, and they only have maybe 15 atoms worth of density. So a layer 15 atoms thick will reflect light normally, kind of thing. So they kind of know they're catching all of the photons by at least the 15th layer. Those kind of experiments. Now I can't say they've done those very well. I can't say I know about all of them. But I'm just saying that's the general principle, that they have some notion that you can miss the first atom in a substance, right? And you can miss 2 or 3. You can fall through the spaces, but they are definitely big enough that you can't, you're not going to go a million atoms through a substance without hitting something. So the pieces are definitely big enough that it can't be any 99.99% empty space kind of argument. They're a lot thicker than that. So obviously nothing implies infinite small here, So again, whether I make the quanta 100 times smaller than the electron, or I make them 1,000 times smaller, it probably isn't going to make much difference to a model's function. The real point is the little bit does move the electron a certain amount of distance, and that's the only part that really matters. It imparts momentum. It's probably enough on that. Alright, infinitely small packed together all over the universe, going in all directions. Yes, of course, that's the way it works. That's pressure. Okay. Otherwise, gravity would not grow linearly with mass. So this is another argument that gets, you can't just apply your intuition, because it's not going to be sufficient to the complexity of the, maybe I'll pause so I can properly erase the board. Be right back. Yeah, I'm back. All right. So I just thought of something else too. The whole, I've made points about the fact that, conventional physics makes arguments that there's, obviously there's no drag in space or something, and I can point out how electrons and protons can't fly through space freely. They can't survive it. Yet a simple nuclei, of helium that only has, 4 of those things, or 5, whatever, that can make it, and so you can use your intuition and try to figure out, well, why does this thing that's only 4 or 5 of these things, why does it escape the same problems this thing has? Well, the truth is because this big thing is now going to hit things that are like atoms. There are no free electrons like in space. So when it's flying through space, it's just going to end up hitting one electron. So it's going to be this big thing against one electron. So it's always going to win. It's like playing a card game, war or something. When you have a deck that's all aces, and kings and jacks and queens, and you're always just going to hit a piece of the atom. You'll never hit the whole structure of something. Well, not never. There's obviously meteors in space and little clumps of stuff, but the odds are you can get through space without ever hitting one of those. So it's always just you against an electron, and you win that battle every time. So you can go quite far without losing too much of your momentum, where these guys, no chance, because they hit the electrons and protons, and it's 50-50 who loses their momentum. So there's no likelihood that you're going to be able to maintain your momentum going through space if you're an electron or a proton. And that doesn't even get to the the elemental thing that the field energy itself is going to stop you, because you're moving into it. That's a whole nother argument about how you overcome drag. But I just mean that these are just real facts, and they're facts nobody plays with. Nobody shows you how to model any of those facts. So you're implying that my theory has some sort of deficit when I'm making the clear argument theirs is the one that has all these deficits. Your intuition should completely fail when asked to understand, well, how does a bent space work? But you don't do any of that. Anyway, so the one I wanted to get to was, so gravity. And so he's sort of talking in terms of you couldn't make a black hole, or you couldn't get this linear relationship with gravity. Now, clearly, the fact that you're gravitational, the fact that you have absorbed some energy in a direction, will be felt by the gravitational equation for an infinite amount of space, in the sense that you could just go forever and there is some effect per square inch at a distance. Now, obviously, if I was spitting paint into the universe, you could understand that there'll be some places in the universe where paint never goes. But over a square area, you could get a certain number will eventually go in those directions. But yes, some places in space, no matter how far you go an infinite distance, there'll be no paint that'll ever hit that spot. But an average over an area will still exist. Some will be in that direction. It's just that it's going to be spread so thin, that there'll be gigantic areas where there's one little drip of paint hit there and one little drip of paint hit there, and that distance can become billions of miles where no paint ever hits. But anyway, that's perfectly consistent with the math. So the other problem is if there's an external force that you're sort of using up, going through matter. So I make matter big enough. The idea would be is that all of the force from one side, would be in some sense absorbed, through the process, and nothing comes out the other side. So it becomes very, very strong gravity, in the sense that energy goes in and nothing comes back out. Okay, so but yes, clearly that would have to be a very dense object. So the universe already has in it suns of very different sizes. I mean, the biggest star in the universe is speculated to be, quite substantially larger than our sun. Our sun would be this little dot, and the biggest sun in the galaxy would be this bigger dot. But why isn't there something even bigger than that? And I would argue it's because these laws do break down, that you can't easily do that. So if you absorb all the gravity, you could argue that the gravity doesn't get any, you can't make, so if this is the size you have where the energy goes in and it completely gets used up. It can't get out. Okay, so nothing gets out. It doesn't change the fact that you still have tremendous strong gravity. So you would have gravity that would be 100,000 meters per second on the surface, very, very strong. Some, you just make up a number, but yeah, 100,000 meters per second gravity. I mean, we have 10, 10 meters per second. So versus 100,000 meters per second might be the size you could get, and then you use up all the gravity. But whatever the size, doesn't matter. The fact would be, though, is you could still grow. That is, you could still get bigger and bigger and bigger. You just wouldn't, the surface gravity wouldn't get any stronger. That would be the only rule. Now, we don't know if these things exist in space, right? I mean, dark holes, we don't know. We wouldn't know if there was a dark planet or a dark sun, right? Because it wouldn't be radiating. And if it has intense gravity, it wouldn't be radiating, right? It would be absorbing. Anything that goes in would be absorbed, and nothing would ever come out. So it's theoretically possible to have some sort of dark thing in space that has intense gravity at this level of intensity, whatever the maximum amount of gravity you could create. But the key is that as you're making it bigger and bigger, so even if I'm piling on and I can't make the surface gravity any bigger, I'm making the internal pressure bigger. So the bigger I get, the more all of this mass, is putting pressure on the interior of whatever it is. And you could argue that this is why things supernova. This is why things can't get. That's why we don't have any mega suns. That's why we don't have any galaxy, suns the size of a galaxy. It's because the pressure would get too great, and the atoms, the electrons and protons, would end up too close to each other, and they would reject being that close. They would create tremendous amounts of internal energy. Impacts between force, and electron, and that's all you're counting, right? So theoretically, if I put two electrons so close to each other that the impacts that they're hitting each other this maximum amount, this insane number of times per second, there is an impact pushing them apart. You could understand that that's a theoretical, almost an infinite amount of pressure that you could create. And so that's why, you could say that once you've smashed electrons so that close to each other, they will be creating so much pressure going out that no pressure could compensate for the amount of pressure they're creating by their proximity, and therefore, boom, the damn thing explodes. So, now we don't see anything exploding beyond supernovas, so there's good reason to believe that these non-suns don't exist, but who knows? I mean, neutron stars do, and that's a whole different theory, but the reason why they are compatible is because they have protons and electrons properly ordered next to each other. I mean, that's the nature of a neutron, a proton and electron. And so they're nicely packed in order, so they're mixed, nicely packed, so you don't have this pressure problem, because you have electrons between every proton, and therefore you can get them closer together. That's probably enough of that. Probably. Mass above a certain level, and also on the micro level, we would observe less predictable behavior. So again, you're just making that part up, frankly, as far as I'm concerned. You're speculating about somehow it doesn't work. No, there's no reason to think it doesn't work. I mean, it can be explained. Now, you don't want explanations, that's your business. But you have just nothing, to sit there and make this assertion. We would observe less predictable behaviors. Why? I mean, you've created some conundrum in your head that doesn't have anything, to do with anything I've modeled, or any reason to believe. And you certainly didn't draw it. So I'm supposed to see a problem, you're mechanically not showing. And it's based on a premise that clearly, you want to make the force infinitely small. That's your business. I wouldn't. Anyway, if that description of momentum bits holds, it wasn't much of a description, frankly, of momentum bits. Again, intuitively, intuition based on very, very little information. The photons must either be made of something else or be really long strings, of specific frequency. What do you mean a string? So, I mean, you're just making this crap up. It really has nothing to do with anything I'm arguing. I mean, why would you even extrapolate from what I pointed out in the video into this kind of, I pointed out that photons aren't clumps, and now you're turning them back into strings again. So, I mean, I overtly said that in the video. I mean, I didn't draw it all because, yes, I've done it in other videos, and, I don't like being horribly redundant if I don't have to be. But apparently I have to be, because none of the commenters really want to know what, There are playlists. There's a playlist called Subjects, and there's a few videos in there that'll probably tell you the story. I mean, there's one on gravity, and there's one on energy, and there's one on photons. If you watch those three, okay, then you won't be saying things like this, because you'll understand I would never suggest a photon is a clump, right? So I said right in the video, photon isn't a clump. It isn't a particle in that sense. And it's certainly not a wave. If you have a wave, waves have components, right? To have a wave, I have to have components to the wave, right? If you watch an ocean wave, it's lumps, right? And the only part that matters are the lumps. And so, you don't have to think of it as some continuous thing, like it's a string. It's not made out of string. The actual atoms of this lump aren't really giving a shit about the lump over here. That looks a little bit, well, anyway. You'll make three of them, then it won't look like that. But, this one doesn't care about this one. They'll care about that one, the atoms. And that's all that really matters, is the density of the atoms, the amount of pressure. So clearly I have pointed out in other videos that I think a photon is spread. Okay, it's momentums, pieces of momentum, bits of force at a frequency and at polarization. Now the trick is the polarization is very large, right? I mean, invisible light in the 500 nanometer range means that you're, 500 nanometers is a lot of atoms. You don't think of it that way, but the frequency of the light is actually, 1,000 atoms large. And that means the polarization, by all reasonable theory. Is this thing making noise? Yeah, it is. Damn. So that means the polarization, by reasonable theory, everybody sort of thinks these two things is proportional, the frequency and the polarization. That means the polarization is 1,000, 1,000 atoms. So you can sort of understand that this bit is 1,000 atoms away from this bit, right? This distance is 1,000 atoms. So a photon is a very large thing, in a sense. Atoms this big compared to the photon, right? But the elements of the photon are clearly much smaller than the atom. So the photon is, if you want to describe something as being mostly empty space, the photon would be the winner. Okay, that's the one that has, a tiny percentage of it is actual bits of energy. And if you're going to contain it in a container, yes, the container is mostly empty space. But clearly what the photon is doing is it has to hit an atom, and then it has to hit another atom at precisely the right timing. So the energy from this atom combines with the energy from this little bit, and now it's capable of producing electricity because it's going to eject the electron. And that's how a photon works. So a photon doesn't hit the tiny, it hits, the energy hits the tiny spot and one electron, but the photon itself has to hit more than one electron to cause electricity. And so the photon is just a pattern. It's a frequency. I've made this argument. It's a tipping point. Okay? Tipping. Yeah. Okay? And that's the intuition you should be applying, is understanding that you're creating tipping energy. You're hitting a system, causing a motion, and then if you hit the system again before it has time to rebound, you can cause a tip, cause it to do something like electricity. And then you say photon because it made electricity. Now the same energy can hit the surface, but if it doesn't hit it with the right timing, no electricity. Okay, you have heat. All right, you have some other reaction, okay, that won't be electricity, and you'll say no photon, but it's still there. What I'm clearly arguing is things like the two-slit experiment. The dark spots are only dark in the sense that there's no photon there, right? So if I have a darks here, there's still energy hitting these spots. There's still bits of a photon, bits of momentum. They're just out of phase. They lost their frequency. They're not doing the proper frequency thing. Too close together, too far apart, not the right frequency. So no photon, no electricity made here. No rebound of no indication of that a photon hit, because it's not doing what photons need to do to be considered photons by the matter. And here it is in phase, and so it can now reflect a photon. All right. Yeah. But I've been through all this stuff. So, you're saying there's an intuitional problem, and yet you're making very specific arguments about very specific phenomenon. And that's just sort of bogus, in my opinion. You're implying you have some good reason to doubt, and oh no, it just doesn't seem like it fits. You didn't really give it any fair chance to fit, did you? So, I'm going to take this comment as just hostile bullshit, frankly. Because you're just saying, what if, what about, anybody can do that to anything, all right, to make it seem like it doesn't work. But it really isn't that complicated. I mean, it's less complicated than your average lawnmower engine. But that you can't just make assumptions. If somebody gives you a very undetailed description, well, gasoline goes in and it combines with oxygen and it explodes in a cylinder. Well, what happens to the pressure of the gases? Well, there's valves to control the pressure. Oh, well, what happens? Doesn't the exhaust create some residual exhaust that stifles the capacity of the, And then you explain, well, that's part of what the valves are doing. They're actually allowing the internal pressure to push the exhaust out the pipe, So you want to play this game, but you're playing a game. Okay. The photons must either be made of something else or be really long strings, whatever, of specific frequency momentum bits. Strings of bits, oh please. For them not to occur often. For them not to occur often from the many random interactions. So you think the precise frequency required, that is, you would have to land. You hit one of them hits the surface, another one hits the surface at exactly the right distance, at exactly the right time, and then a third one hits at exactly the right distance at exactly the right time. Would be a coincidental problem. Now, coincidences aren't going to produce too many random photons. And the truth is that there is some reason to believe there are some random photons created by things like gravity. And the photo detector, the photo multiplier sort of gives you an indication of that you can crank up its sensitivity and it'll start producing photons inside of a lead box. You can put it inside of a lead box and it'll sit there and say, photon, I saw one. Now, maybe it wasn't a real photon. Maybe it was just heat converted into a photon. Anyway, um, from the many random interactions of momentum bits with mass, blah, 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 blah. Probably some of this was clarified before. Yes, it has been. But I didn't watch most of your videos. Well, you don't have to watch most of the videos. So again, you're implying that it can't be done. It's just too arduous to know what you're talking about. No, you have to watch 4 videos, maybe. You just watch the one on photons. This was mostly about photons, so just watch the one on photons. What is a photon? That's what it's titled. What is a photon? And then you might not be as confused. Hope it makes sense. Thanks. Oh, well, it doesn't really make sense to sit there and say I'm going to intuitively, with the crudest of insufficient knowledge, analyze the flaws. Yeah, I'm not really. Yes, frankly, that's what I'm not terribly interested in. That's why I'm trying to get a physicist in here, so I can have a conversation with somebody who can actually defend the Standard Model with some sort of competence. And will be able to understand questions that are asked, and has some knowledge of the history, so that everything doesn't have to be explained to them. But whatever. Okay, I answered your question. I'm not sure I liked it much, but whatever. Thanks for participating, I suppose. But again, the participation is on your, you're playing the game by your rules, not what I think are fair rules. I dissected and completely annihilated any credibility to the Standard Model. I mean, I gave you all kinds of reasons not to believe any of this horse shit. And, this is the crap you provide in response. So you didn't provide any defense of why they didn't repeat the Eddington experiment. One of the most spectacularly famous experiments in the history of physics. Never repeated, right? I mean, that's one of your fundamental premises of your science. Is repeat, repeat, repeat. Guarantee that you're right. Guarantee that you have good reason to believe. Prove it. Not just assert it, prove it. And don't sit there and come into court with, well, look, we were looking for fingerprints and, we made some smudgy marks. And one time when we put it in the computer, it said it was that guy. Well, 9 other times we put it in the computer, it says it was somebody else. That's true. But we're just going to pay attention to the one where it says it was him. There's all kinds of ways to cheat in these arguments. And I'm just saying, it seems kind of cheaty of you to play this game like, pretending you got me in some way. Like there's some, oh yeah, well your theory doesn't really fix anything. Bullshit. And again, not even addressing a single one of the huge deficits I pointed out existing in the existing theory. They don't even know how a beam splitter works. You will show me where they're showing you how a beam splitter works? Show me one video where they show you, well, see, the photon bounces off the mirrored surface. Okay, I don't know why I did that. I didn't click on anything, not that I know of. I don't recall clicking on anything anyway. Yeah, so I guess I deleted it. No, here it is here. This is exactly what all these New Age cults use to brainwash people. They say, yeah, you can just move into another parallel reality and proof. Oh, I guess that's poof. Everything is different. It is a cult. Well, I don't know if it's a cult. It's a pretty established religion, frankly. I mean, it's kind of silly to call physics a cult. I mean, it's running the world right now. I mean, it's this billion-dollar industry. It's not exactly a cult. It's not some sort of fringy little wacky group of religious kooks. It's a well-established theocracy, with the Pope buildings and all. I mean, they have all kinds of established, royal institutions and all kinds of places, where they do their little caballing. So, yeah, not even close to a cult. Not a real, I mean, you call it what it is. A dogmatic, archaic, impossible of fixing itself, popey Catholic religion. That's all it is. It's like Catholicism. It's so frickin' behind the times, so to speak. It doesn't even do the Methodist thing or the it doesn't even try to correct its monolithic, moronic flaws. I mean, never even fixing plus and minus again. Nobody can defend that. It's really quite critical to really being able to rationally model charge and magnetism, getting those things right. The fact that they're wrong does create a huge disconnect in the sense that now their mathematics is forced to create some lie. Current goes in the opposite direction. No, current doesn't go in the opposite direction. It's going in the same direction as the voltage, right? I mean, that's what they're basically saying. The velocity of the stream of water is going that way. Or, the velocity is going this way and the mass is going that way. I mean, it doesn't, it's terrible. Anyway, so I'm just saying this is why I'm not appreciating this comment much. Okay, I'm pointing out the huge flaws in your physics, in the conventional model, and you're nitpicking my physics. Seems bullshit to me. So anyway. Alright, we'll make it a short video because, I'm really sick of the whole thing. I mean, we got $2,000, okay, to any channel with more than 100,000 subscribers to ball up and allow me to counter-argue the conventional nonsense. All you have to, at minimum, you just have to play a 17-minute video on your channel. That's the minimum I'm asking for. For $2,000, all you have to do is give me 17 minutes, okay, to see if any of your audience, see if your entire audience is brain dead. Yeah, okay. That's all. I'd clearly like the conversation, though. So if anybody is a physicist out there, hello, anybody have any kind of, it doesn't have to be a strong physics degree. I mean, you have a good degree in biology, which means you had to take some physics, and you have some competence, some knowledge, of the basic experiments and the basic concepts. Make me an offer. You'll talk for $50 or $100 or some kind of thing. Because I really don't care. I mean, I just want to hear this argument. I just want a chance to interrogate. I just want to hear a physicist, somebody who defends conventional physics, explain to me why they never have repeated the Eddington experiment. I mean, it's a glaring omission. And just, 3 years ago, we had a perfect eclipse. So even if you didn't do it from space because there's some sort of rule that all your satellites are afraid to look near the sun or some kind of bullshit, some bullshit you'll make up. And so you don't take advantage of the 400 times better resolution in space. Even if you don't do that, I mean, we had a perfect eclipse, over North America, and nobody with a better telescope did the experiment. I mean, that's pathetic. And again, doesn't it just completely violate your obligation to repeat experiments? Yeah, I think it does completely violate it. But the truth is, Einstein's theory is horseshit. I'm just telling you, there's just absolutely no good. You talk about intuition, this guy. You think there's a rational intuition? So no other force, there's no example of any force ever bending any other force. So we can't make electricity bend magnetism or gravity bend this, magnetism or gravity bend light. Well, at least not in the lab. We can't make any of this stuff happen. Right? And it's supposed to be, photons are supposed to be electromagnetic radiation, and yet we can't bend them with magnetism or electricity. Yet, we're supposed to believe that gravity can do it, and that it not only does it, but it does it twice as much to light than it does it to anything else. So it moves electrons. It's harder for gravity to move an electron than it is for it to move light. Where's your intuition there? Why aren't you telling me, hey, I have this intuition thing, and I have to agree with you that I can't find any intuition that makes that make sense. When they tell me that gravity bends light twice as much, yeah, my brain intuitionally says, wow, that's really bizarre. It's really bizarre that a force is bending a force, but now it's, something moving the speed of light is bending something moving the speed of light. Because there's just no evidence you can do any of that crap. You can't crash laser beams into laser beams. You can't crash laser beams into magnetic fields. You just can't do it. And so here in this case, this one case, you can do it, and it does it twice as much. What's the theory? Somehow the bending of the space is more for light. Somehow space bends more for light. And you're just telling me your intuition is okay with that. My intuition didn't have any problem with that. See, that's all I'm saying. So maybe half your comment was, my intuition has a lot of problems with the conventional model. But looking at your model, I also have some problems. See, I might have felt a little bit better about it. But that's not the game you played. You didn't really address anything brought up in the video. Nothing, none of it. All these things they say based on tiny, tiny little shreds of evidence. I mean, they're just almost invisible. And frankly, they are invisible, I'm arguing. You can't possibly know it to be true from what they offer you as evidence. LIGO has given you evidence that you can't possibly look at it and say, oh yeah, I totally get that. You can't. You can't understand it. You don't know the mechanics. And if I go through the mechanics with you, that the beam is actually bouncing off 1,600 mirrors, and yet they're precisely measuring two different beams that are bouncing off 1,600 mirrors. How do they know how far the beam went into the mirror each time? How could that possibly be a known variable? I would argue it can't possibly be a known variable. It can't possibly do anything but actually create their fake signal. Bouncing photons into mirrors 1,600 times will create a lot of noise. And that's all they need. Give me enough noise and I'll find a dog barking. Right? Give me enough potato chips and I'll find Richard Nixon. Or Donald Trump potato chip, to use a more current reference. And I'll find one. That's intuitional from my perspective. But somehow your intuition is fine with their bold claims. We heard two black holes convert matter into bent space stuff. Not energy. No. Not E equals MC squared energy. No. They converted the matter into bent space. That pushes and pulls back again. See, they had to make it a push-pull wave, because if they didn't, they wouldn't be able to explain why the universe around this thing, wherever this event took place, the whole universe around it should have had this huge push away. See, if they made it regular energy, everything would push away. And they'd have a big empty space in space where this event happened, because everything would get pushed away by the energy release, the 3 solar masses all at 1 second released. The sun's whole lifetime of energy released in 1 second. 3 times. Yeah, 3 times that. Obviously, that's going to clear space. That's going to make a big void, where nothing will be there because everything got pushed away. So they had to turn into a push-pull. You really believe that crap? Your intuition is fine with that? Oh yes, they converted mass into push-pull. Sorry, not even close. Have they ever explained any of it? No. Have they drawn any of it? No. It's all crap. Fucking mathematics. They have mathematics that does everything. Mathematics knows all. The greatest superhero of the universe is the mathematics. Because the universe is all made out of little numbers. No, it really isn't. It's made out of quantities. That part's right. But they have no clue. Because they think an 8-pound bowling ball has twice as much energy as a 16-pound bowling ball, thrown with proportional force. So you throw the two with exactly the same amount of muscles, use just the same amount of muscles, and you throw the 8-pound ball and you throw the 16-pound ball, and the 8-pound ball has twice as much capacity to annihilate pins. And yet no professional bowler in the history of mankind has ever used an 8-pound ball. So again, your intuition fails there. For you, it's very intuitive to think that, oh yes, those 8-pound balls have so much, wrecking balls are always small because, to knock a building down, you got to move things fast. The faster you move the wrecking ball, that's what's important. How heavy it is, who cares? That's your intuition, right? They're really retarded to have that big heavy crane holding up that big heavy ball to knock down buildings, because it'd be so much easier if they just use a little light crane and a little light ball and just throw it quicker. They would get the job done so much faster because they have twice as much energy. So you don't have an intuitional problem with what they say. You think that, you think you can make magical energy just by throwing light things around. I throw a light thing, I made twice as much energy. No intuitional problem. And that's one of the core things of their whole frickin' physics, all right? It's right there in the nucleus of their physics. It's not like it's some peripheral little thing over here. The kinetic energy formula is right in the middle of it. And it's a piece of shit, and you won't admit it. You won't just fess up and say, okay, you got me. I can't make any intuitional sense out of this silly notion that because I throw a lighter thing, I'm making energy. Yes, that's really stupid. Okay, I concede. You can't do that. That's why I don't like you much. Okay, so even though you were polite and you did your little blah, 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 and your little typing and pretended to be interested, it doesn't look like it to me. It just looks like more bullshit from another religious kook. Okay, you're just one of the polite religious kooks. Alright. Yeah, I made my point. Alright. But yeah, there's really this whole cancel culture thing. I'm getting canceled by YouTube, clearly. And so I need eyeballs. I need people that can make an argument, and there just aren't any. The world is all pussy. I mean, it's just, there hasn't, maybe there's been no real testicles born on Earth, in decades maybe. I don't know. Demographics are interesting too, right? Because it's all, it's like there's two big hunks, 30%ers kind of thing. The ones between like 18 and 27 or whatever it was, 30. And then there goes, 50 to 60, 5-ish, and those are the two big categories. And the women's, I'm afraid, I used to have some women's pulling power, but yes, I have gotten old. It's ruined all that fun. Because we're down to like less than 2% female audience. And there's a lot of women in physics, right? I mean, if you look at physics college classrooms, it's full of girls. So they got to be out there somewhere. Who knows where? Yeah, they're not here. So anyway. But I'll endeavor to persevere. That's all I can do. But I got to find a new strategy. I mean, we're going to take more money, I guess. I'm just going to have to keep upping the ante. Sooner or later, there'll be a number where they just can't refuse it. Where they're just going to have to take I'm going to show you to be a retard bait. They're going to just say, yeah, well, I'll just hope it goes away. I'll post the video and then I'll hope nobody saw it and nobody pay attention. And I won't have to defend physics. But I guess that's what it's going to take. I don't know. We'll see. I mean, maybe I'll have a special, I'll have a one-day event, where I'll make it $2,500 on that one day. It hurts me. I mean, it's it's a lot of money to have to pay, to do work. I mean, it's work to, construct the argument, put it in the right words so they can't evade the question, to keep dealing with but mathematics says, and the mathematics is the most proven theory in the history of mankind, 2 + 2 = 4. It's the most proven theory in the history of mankind, so it proves that we're right. Because if it wasn't right, then 2 + 2 couldn't equal 4 if math didn't work. Yeah, and then you have to explain. I'm not talking about adding two numbers. I'm talking about when you do this bullshit where you say f equals w times Forky thing, and then Forky thing divided by 2 equals, w squared, and that's the crap I'm talking about. Lots of room for shenanigans when they start replacing things with other things that aren't necessarily equal. Anyway, all right, till next time and such. Yeah, that's enough. This has been a DraftScience video presentation and such.